This is one of a series of lectures, revision lectures from the Further Maths Support Programme. In this lecture we'll be looking at Edxecel Mechanics 1 and the topic is moments. The specification for Edxecel says that you should understand the idea of moments of a force and then looking at simple problems with forces which are acting parallel to each other. The moment of force is defined as the force multiplied by its distance from the axis. And then the other thing that's required is the idea of equilibrium. And in equilibrium, the sum of the moments about any axis is equal to 0, and also the sum of the forces in any direction is equal to 0. So two things we can use in equilibrium: the idea of the moments summing to 0 and then the forces in any particular direction equal to 0. In general, there are two types of questions which are used. First one is where we have something like a beam resting on supports, so that there are then forces which act vertically on the beam at each of the supports. These are the reaction forces. And of course the weight of the beam at its centre. An equivalent sort of situation might be somewhere where a beam is supported by two cables, where we have tensions in the cables. And again, the weight of the beam at its centre. So those are the basic ideas involved then, so we'll now look at a couple of questions to illustrate those ideas. First question is from the January 2011 paper. Just reading through the question first of all, then we have a uniform beam of length 6 meters and mass 20 kilograms. The idea that it's uniform means that we can talk about the weight acting at the center. So on the diagram, I'll first of all draw that in. The weight W being equal to 20 multiplied by G newtons. It says the beam is in equilibrium in a horizontal position on two smooth supports. One support at C, which is 1 meter away from A, and the other end at B, as shown, as it says, in figure 1. So often we've got a diagram given to us, but not always. Sometimes you need to draw your own diagram. The first part of the question asks us to find the magnitude of the reactions at B and C. So we will have two reactions acting vertically. One at C and one at B. So we could call those, just for convenience, let's call this one R subscript C and this one R subscript B. The second part of the question, once we've done that, adds in another mass, a buoy of mass 30 kilograms at some point, and then the beam remaining in equilibrium. We're then given some information about the reactions, saying that they're now equal, and we need to find the position that the buoy is standing in. We'll leave that until later on. So the first part of the question then looks at the situation as we've got in the diagram at the moment. So in part A, it says find the reactions of the beam at B and C? Well, we can do this first of all, let's say, by taking moments about C. If we took moments about point C, then the reaction at C has no moment because it's zero distance from C, and so we'll get an equation involving reaction at B only. So moments about B, the 20 kilogram mass, so 20 G newtons, is at a distance of 2 meters from C. So we've got 20 G multiplied by 2, acting in a clockwise direction, and then in an anti-clockwise direction we've got RB, so minus RB multiplied by 5. And then because it's in equilibrium, we can use the fact that the sum of the moments is 0. It's quite a straightforward equation to solve then. We get that RB is equal to 20 G multiplied by 2 divided by 5, or in other words, it's 8 G newtons. Quite okay to leave your answer as 8G, although you could, if you wish, express it in terms of a decimal. The second part of the question says find the reaction at B. We can do this in two ways. We could turn our attention then to moments, this time about B, and do a similar thing to the first part of the question that we've just done. However, using the other idea of equilibrium says that the forces in any given direction are equal to 0, or sum to 0. So if we now resolve in a vertical direction, we can say that RB plus RC and then minus 20G is equal to 0. Of course, we know what RB is, so that we can therefore say that RC is equal to 20G minus the reaction at B, which we've already calculated as being 8G. So it gives us a total of 12G newtons for the reaction at C. In part B of the question, we introduce another mass. Is a boy of 30 kilograms standing at some point that we don't yet know, so we have to put it in as some unknown distance. But the force will be a vertical force, 30G. At some distance, we would like to find the distance from A, so let's call that distance from A X. We now have a situation where again we can use moments. We're told that the reactions at R and B are now equal. So we can say, well, the total reaction then, RC and RB being equal, must allow us to equate 2 times that reaction, 2R let's call it, to the downward force of 30G plus 20G. So in the first part of that question, then we can say that 2R must be equal to the downward force 20G plus 30G. So therefore the reactions are now equal to 25G. Having done that, we can take moments about any point. Let's take moments about A, because that's the distance that we would like to find. AD is equal to our distance x. So taking moments about A, we have the reaction at B, so which is 25 multiplied by the distance 6. The reaction at C is 25 multiplied by 1. And then in the opposite direction, so minus, we have the weight of the beam, 20g at a distance 3. And also now the 30g at the distance x that we're trying to find. And we can equate that to 0. Well, in total, we've got 175 minus 60, so it gives us 115g must be equal to 30g times x, which means that x is equal to 115 divided by 30, or 3.8. And of course it's a distance, so it's meters. So x is 3.8 meters. Looking at the marking now for this question, in the first part of the question, working out one of the reactions by taking moments is marked as M1 A1 for a correct equation, and then a final A1 for the answer. For finding the second reaction, method mark M1 and accuracy mark A1, so giving you a total of 5 marks for the first part of the question. In the second part of the question, there is a B mark, so no method involved there, just a B mark for the 25g for the reactions, each of the reactions, and then a method mark with 2 accuracy marks for the equation, the correct moments equation, and finally an A mark for the answer 3.8. So again, giving you a total of 5 marks for the second part of the question. In the second question that we've got then from January 2010 this time, we have a pole length 3 meters and weight W newtons. So this time it's an algebraic question. The pole is held horizontal, it says, with 2 ropes attached at A and some point C, which is 1.8 meters from A. And then, in addition to the pole, there is a load, 20 newtons, attached to the rod at B. It says we're going to model the pole as a uniform rod. That means that the weight can be thought to act at its center. So we've got the W acting down here. And the ropes are inextensible strings. We can put in tensions here. Let's call them TA and TC, which are supporting the rod, and then the particle at the end has a weight of 20 newtons. In the first part of the question, we're asked to show that the tension in the rope the pole at C is given by an expression 5/6W plus 100 over 3, and that's newtons. Having done that, we should find a similar sort of expression in terms of W for the tension in the rope at A. And then we're going to solve for W, given some extra information in part C of the question, that the one tension is 8 times the tension, the other tension. So 3 parts of the question. We'll start off with part A, trying to find the tension at C. So we're trying to find TC. It makes sense then to take moments about point A. So if we take moments about this point, then there is no effect of the tension at A because it's 0 distance. Therefore, moments about A tell us that we have 1.8, the distance multiplied by TC is the moment in the anti-clockwise direction. The other direction, we have the weight W, which will be at 1.5 meters because it's a uniform rod, so halfway along, 1.5 W. And then at the end of the rod, we have 20, so multiplied by 3. And because it's in equilibrium, those moments sum to 0. This means that TC is equal to 1.5 W plus 60 divided by 1.8. And that is equal to 1.5 over 1.8 is 5 over 6 W, and 60 over 1.8 is equal to 100 over 3. Perhaps what we should do is maybe write it as 600 over 18, because this is a show that question. We've actually been given the information that we need to find, so we need to be careful to show enough working to say that we've done the question rather than just copying the answer from the question itself. In part B, we're asked to then find the tension of the rope at A. Well, again, we could do this by moments, by taking moments perhaps at point C. However, easier than that is to look at the forces vertically, so resolving vertically, and equating those. We can say that TA plus TC minus W minus 20, those are the forces acting downwards, they must equate to 0. So the equilibrium now for the forces vertically is given by that equation, and therefore TA is equal to W plus 20 minus the tension at C. This is W plus 20 minus 5/6 W plus 100 over 3. So that's 1/6 W, W minus 5/6, 1/6 W, and then over 3 we've got 2, sorry, it should be 20 there. So 20 is 60 over 3. 60 over 3 minus 100 over 3 gives us negative 40 over 3. So there's our expression for TA. In the final part of the question, we're told that the tension in the rope at C is 8 times the tension in the rope at A. So in part C, we're told that the tension in C is 8 times the tension at A. So now we have an equation so that we can say, well, the tension at C, 5/6 W plus 100 over 3 is 8 times the tension at A, 1/6 W minus 40 over 3. And if you solve that, we can show that W is equal to 280. Okay, looking at the marking for this, in the first part of the question there's a method mark for taking moments, and then 2 marks for getting the correct moments equation. Having done that, an A mark for solving that and showing the correct solution. In the second part of the equation, a method mark, an accuracy mark for the equation, whether you've done it by resolving as we did here or by taking moments, and then an A mark for the final answer. And then in the final part of the question there are 3 marks available. Firstly, a method and accuracy mark for getting the equation stated here, and a final A mark for the answer 280. Okay, that's the end of that lecture. Other lectures are available for the rest of the mechanics and the other modules that you may be interested in, and further information can be found on the website for the further mathematics.